Hello everyone, welcome to Apna Guruji, and in this video we are going to discuss about the physical quantities and measurements. So in this full video we are going to discuss all the concept of the chapter physical quantities and measurement, that is the chapter of ICSE class 8, and this is the second chapter. And in this video we are going to discuss all the details and all the important concept of this chapter. So first you have to know that what is physical quantity. So physical quantity is defined as that whatever and the quantities which can be measured, that is known as physical quantities, and we can simply say that it is a measurable quantities. So physical quantities are basically divided into two categories. One is fundamental physical quantities, another is your derived physical quantities, and another is your derived physical quantities. So the fundamental physical quantities are all those quantities which can be defined independently, or they don't depend upon other physical quantities to identify them. But the derived physical quantities are obtained by the multiplication or the division of the fundamental physical quantities. So in your text, that is first concept is density. So in your class you have to first understand what is the density. So density is the derived physical quantity. And first we have a question that take an iron ball and wooden ball of the same radius. Now you can say which one is heavy. So take a pause and answer that. So I think all you have the answer, that is the iron ball is heavier, because the volume of the two objects are same, but the mass per unit volume of iron is more as compared to the mass per unit volume of the iron ball. That's why it is heavier. So that mass per unit volume is known as the density. So density is simply defined as the density of a matter as the mass per unit volume, and we can give the simply formula density equals to mass by volume. Density is the primary property of a matter. Every substance has different density, so it is substance to substance the density will be vary. So there will be unit of density. So unit of density is simply the unit of mass by unit of volume. So unit of mass in SI system, that is kg, and unit of volume, that is SI system, that is meter cube. So in SI system the volume of the density, the unit of the density will be kg per meter cube, and in the CGS unit, that the unit will be the density of is gram per centimeter cube. So here is the relation between the SI unit and the CGS unit, that is 1 kg per meter cube equals to 10 to the power minus 10 gram per centimeter cube. So next is our measurement of density. So measurement of density is simply measurement of density is different in regular solids and irregular solids. So in regular solids we have some formulas, and we have to remember that formula to calculate its volume, because mass can be defined simply by a weighing machine, but volume we have some formulas for regular solids. So regular solid as like cube, cuboid, sphere and cylinder. So first we have to calculate the volume, and we have already identified the mass by weighing machine. So we can simply calculate the density, that is mass by volume. So volume of a cube is given by the formula side cube, and volume of the cuboid is length into breadth into height, and volume of sphere is 4 by 3 pi r cube, and volume of cylinder is pi r square h, where r and h are the radius and the weight of the cylinder. So you have to remember all these four formulas to calculate the density, because without getting the volume you cannot calculate the density. In case of irregular solids, we use some devices or instruments to calculate its volume, as like example measuring cylinders. Using a measuring cylinder also we can calculate its volume. So in case of liquid we cannot use the formula like volume of formula like cuboid cylinders. So we use measuring cylinders to calculate its volume, and mass is simply by the weighing machine. And we can also use the measuring beaker, and another is your eureka can. So in eureka can, simply the can is filled up to this level, and whenever we drop any object on it, so simply the amount of water or amount of liquid released, that is the volume of that particular object. So it's simply given by the volume equals to V2 minus V1. V2 is the volume, and measuring cylinders, by using this you can calculate this volume. So this is simplify the density equals to mass by volume. Suppose there is example, so there is water up to level of the 50 and we drop an object and it rises up to 50 to 75. So the volume of the object will be 75 minus 50, that is 25. And by using the weighing machine you can calculate the mass, and simply by putting the formula density equals to mass by volume you can get the answer. And here is the formula: mass by volume equals to mass of the solid by volume of the displaced water. So simply here the displaced water is 25, so you can put the value 25. Density of a liquid is simply calculated by the density bottles also. If the density bottle is filled up to 50 ml, so whenever you drop any object inside this, so the amount of water released, that is the volume of that object. So this is the calculation method, you can skip that, that is not so necessary. And then the variation of density with temperature. So temperature is the important factor to calculate its density, because with the temperature the density will varies. So in case of solids, the molecules are tightly packed, there is no space, so whenever we rise the temperature the molecules not move so rapidly, and the volume will not change accordingly. That's why temperature variation does not affect the density of the solids. It's maybe if you rise a large temperature then the density will vary, but in case of liquid and gases the molecules expands rapidly with the temperature. So when the increase in temperature the density will be decreased, and when the decrease in temperature density will be increased. So it is inversely proportional. And next is the relative density. So in case of relative density we can compare water, kerosene and benzene. When we pour three liquids in a single beaker, we can see there a level is created, so the density is relative, means comparatively with another, that is the relative density. So you have a questions. So whenever you see that is the cork and another is the iron piece, so cork floats and the iron piece is sink. So this is due to the relative density, because the density of cork is less than the density of water, that's why it floats. And in case of this, the density of iron piece is greater than the density of liquid or the water, that's why it sinks. Again we have a table. In this table you can see that is the density are given of the given substances, that is water is 1000, kerosene is 810. So that's why kerosene floats on water. So you can remember this table and you can compare which will float in which substance. So here wood also the density is 800 and the water is 1000, that's why wood also floats. And in sea water the density is 1025 comparatively. So take an example, we have a calculation, that is the mass of a substance is given 5400 kg, and the volume is 2 meter cube. So if you have to find the density, that is volume is given 2 meter cube and mass is 4500, and by using the formula density equals to mass by volume, you can simply write that density of aluminum is 4500 by 2, that is 2700 kg meter cube. Relative density in depth. So we have a container. So you can see that there is an example, uh, there is a flame but the kerosene level is low. So how do you blow the flame? So simply if you have, you can put water inside it, so the rise of the kerosene level will increase because it flows on water and the flame will blow. So this is an example of relative density also. So we have given some values of relative density, that the relative density of water is 1, kerosene is 0.81. So by remembering this you also calculate the relative density or density of substance. So relative density of substance is generally given by the formula mass of substance by mass of an equal volume of water at 4 degree Celsius. In Archimedes principle, the relative density is given, that is W1 by W1 minus W2. Here W2 is the weight of the object inside the water and W1 is the weight of the object in air. So then the same thing, same formula, we have an example. What is the significance of the relative density? So relative density helps us to determine the density of an unknown substance by using density of a known substance. It enables geologists to calculate the mineral content in rock. What are the difference between the density and the relative density? So in simply you can write that density is the mass per unit volume, but relative density is the density ratio of the density of substances. with reference to water. Usually relative density have don't have unit, but density have unit, that is kg per meter cube. Another is the law of flotation. Law of flotation, that whenever you put an object inside water or on the water, it will experience two forces, that is one is weight due to gravity in the downward, and the buoyant force that is given by the liquid. Whenever you put any substance inside a liquid, the liquid will give a opposite force to resist it, that is known as buoyant force. So depends upon this, the object will float or sink. If the weight is more than the buoyant force, then the object will sink, and if it is equal, then it will float on the surface. And it is the buoyant force is very less, the buoyant force is very much higher than the weight, then it will float above on the surface of the object. There is three cases. You can see that weight is greater than the buoyant force, weight is equal to buoyant force, and weight is less than the buoyant force. You can see that example. When his weight is very high than the buoyant force, then the object will sink in the bottom, and when it is uh, less or equal, it will float on the surface, and when weight is greater than buoyant force, it will sink. So depends upon, if very much higher in bottom, comparatively high, that will be float middle, and if is equal to buoyant force, then it will float on the surface. Half of the object will be outside the solid liquid, and half of the object will be inside the liquid. Volume, so law of flotation can be represented in formulas. Volume of a body inside into density of the body equals to volume of displaced liquid into density of the liquid. So there are application of law of flotation also. Our iron ships floats easily because of the law of flotation, because the iron ship, there is a vacuum created inside, and the volume will be low, volume will be greater, and the density will be low as compared to water, that's why it floats. Iceberg floats on water also. And application of law of flotation, other is flotation of fish. Fishes have floating tubes which generally filled with air and hence displace more water than weight. This amount of air is adjustable and hence can be used to gain the lost weight. Flotation of submarine. The submarine in a normal condition floats on water, but when water is sucked in it, it gains weight and gets submerged into water. Flotation in seawater. It is easier to float in seawater than in fresh water because the density of seawater is 1.04 gram per centimeter cube is more than the fresh water. Hence, it is seawater. The displaced water is most heavier than the normal water. Flotation of man in fresh water. In fresh water also, man can float, but the head part is submerged in water because the head part is more density. Flotation of icebergs also. Icebergs floats in water with 11 by 12th part of his volume under water and 1.12 part above it. It happens because density of ice is 0.917 gram per centimeter cube, and that seawater is 1.0404. That's why slightly part is float above the water and remaining part sink. Archimedes principle is used to locometers to determine the purity of milk, and it is hydrometers to determine the density of the liquid. So this is the application of Archimedes principle. Whenever you go to a dairy farm where the milk is collected, they use the lactometers to determine the purity of milk. So the lactometer is designed as the principle of Archimedes principle. So this is all the concept of the chapter physical quantities and measurements. So in your chapter, that is mainly focused on density, law of flotation, relative density. So remember all these concept, and if you feel any doubts, please ask in the comment section. If I skip any concepts that is given in your textbook, please ask in the comment section so that I can make the video in the next. So if you enjoy and learn from the videos, please like, share and subscribe. And if you feel any informative or learning things in this video, please share with your friends also. एंड कीप वाचिंग अपना गुरुजी। तब तक के लिए हम लोग मिलते हैं फिर एक नए टॉपिक के साथ। तब तक के लिए बने रहिए अपना गुरुजी पे। थैंक यू गाइज।